Welcome to 75 Years of AI, Understanding the Four Major Eras. In this video, we'll show you the history of artificial intelligence and the four eras that have led us to today. Be sure to like and subscribe this video right now, and we'll continue to bring you more videos on making your teaching life easier. Now, on to your video. We're here today to talk about something that is rapidly changing our classrooms and our students' futures: artificial intelligence. You might feel overwhelmed by the speed of change, but I want to ground us in history. We're going to explore the 75-year journey of AI, breaking it down into four distinct eras. Understanding this history isn't just an academic exercise, it's the key to teaching AE literacy effectively. We need to move past the headlines and understand the deep cycles of ambition, failure, and eventual breakthrough that brought us to where we are today. This timeline helps us see that today's AI isn't magic. It's the result of decades of persistent work. By the end of this session, you'll have a clear framework for discussing AI's past, present, and future with your students. Let's start by looking at why this historical context is so crucial for us as educators. Understanding the past prepares our students for their future. When we teach AI history, we show students that technological progress isn't a straight line. It follows cycles of incredible optimism, followed by harsh reality checks, which is a powerful lesson in scientific resilience. This historical context is essential for helping students develop critical thinking. They need to be able to distinguish between what AI can do right now and what it can't do, tempering those unrealistic expectations we see in the media. Think about the scientific method: hypothesis, testing, failure, refinement. AI's 75-year timeline is a perfect case study of this process. It shows that major breakthroughs only happen when three ingredients: theory, massive data, and computing power finally converge. If we understand these patterns, we can guide our students to be thoughtful users and creators of technology, not just passive consumers. Now, let's dive into where it all began. The ambitious dawn of AI-3 Era 1. The dawn of AI, 1950 to 1974. Our journey begins in 1950 with Alan Turing's famous question: can machines think? This philosophical inquiry launched what we call Era 1, the dawn of AI. This was a period of extraordinary optimism, fueled by brilliant minds and significant government funding. The key moment was the 1956 Dartmouth Conference, where the term artificial intelligence was officially coined. Researchers genuinely believed that human-level intelligence was just around the corner, maybe 20 years away. We saw incredible early milestones like the perceptron, which was the foundation for modern neural networks, and the ELIZA chatbot, which fooled people into thinking they were having a real conversation. This era was defined by the belief that if we could just write down all the rules of human knowledge, a computer could follow them. They were focused on symbolic AI, trying to hand-code intelligence, but this massive ambition would soon run headlong into a very harsh reality, which brings us to our next era. Era 2. The AI Winters, 1974 to 1990s. The boundless optimism of the dawn era quickly collided with the limits of 1970s technology, a period that lasted nearly 2 decades. Researchers had vastly underestimated the sheer complexity of human intelligence. They realized they couldn't just hand code all the world's knowledge. The computers of the time were simply too slow and lacked the massive data sets needed for learning. When a critical report in the UK criticized the lack of progress, funding was slashed, and the US Congress quickly followed suit. This led to the first AI winter, where research dried up. We saw a brief commercial revival in the 1980s with expert systems, which were specialized programs for things like medical diagnosis, but even those collapsed when the specialized hardware they ran on became obsolete. The lesson here is crucial. Ambition without the necessary computational infrastructure is a recipe for failure. But even in the cold, quiet years of the winter, important work was still happening, setting the stage for the next revolution. Era 3, the Quiet Revolution, 1990s to 2010s. While the public and the funding agencies had largely moved on, a dedicated group of researchers kept working through the AI winter. This quiet persistence defines Era 3, the Quiet Revolution. The key shift here was moving away from trying to program rules and toward creating systems that could learn patterns from data. what we now call machine learning. Neural networks, which had been dismissed in the 70s, started to show real promise. We saw breakthroughs like convolutional neural networks successfully recognizing handwritten digits, and famously, IBM's Deep Blue defeating the world chess champion in 1997. But the real game changer was the convergence of three critical ingredients. First, massive internet-generated datasets, like the ImageNet project. Second, powerful, affordable GPU hardware, initially designed for video games. And third, mature learning algorithms. When these three elements finally aligned, the stage was set for the explosive growth we see today. Era 4, the Cambrian explosion, 2000s, 10s to present. And after decades of quiet research, we finally hit the jackpot. We call this Era 4 the Cambrian explosion because, just like that biological event, AI capabilities suddenly exploded in diversity and complexity. We moved from the lab to the real world almost overnight. This era is defined by deep learning finally delivering on its promise. The key takeaway here is that the three ingredients we discussed, data, hardware, and algorithms, finally converged. Look at the timeline. In 2012, AlexNet crushed the image recognition competition, proving deep learning was superior. Then came AlphaGo in 2016, showing strategic creativity. And by 2022, ChatGPT brought generative AI to every household. Think about your own daily life. AI is no longer a futuristic concept. It's powering your phone, your streaming recommendations, and even the tools you use for grading. This shift from research curiosity to essential technology is the most important change of the last decade. But how did we get from AlphaGo to ChatGPT so quickly? That leads us directly to the single most important technical breakthrough of this era, the transformer. The transformer architecture is the engine behind the generative AI tools that are changing education right now. If Era 4 is the Cambrian explosion, the transformer is the evolutionary leap that made it possible. Before 2017, language models struggled to understand long sentences because they processed words sequentially, forgetting the beginning by the time they reached the end. The transformer changed everything by introducing the attention mechanism. This allows the model to weigh the importance of every word in a sentence simultaneously, giving it context and deep understanding. This breakthrough enabled massive scalability. We went from models with millions of parameters to models with hundreds of billions, creating the large language models we use today, like ChatGPT and Gemini. So what does this mean for us as educators? It means these tools can now assist with writing, coding, and research in ways we couldn't imagine 5 years ago. We have to rethink assessment and pedagogy entirely because the tools our students use have fundamentally changed. Now that we've walked through all four eras, let's step back and look for the bigger lessons. We've covered 75 years of history, and I hope you see that AI development is not a straight line of progress. It's a series of cycles, and understanding these cycles is the real lesson we need to teach our students. Now, the first pattern is clear. Overconfidence precedes failure. In every era, researchers predicted human-level AI was just around the corner, only to be proven wrong. This teaches us humility and realism. The second pattern is that infrastructure enables breakthroughs. We saw that algorithms alone weren't enough. We needed the data and the powerful hardware to make them work. They must mature simultaneously. The third pattern is the persistence through the winners. Even when funding dried up, dedicated researchers kept working, laying the quiet foundation for the next boom. This whole history mirrors the scientific method itself: hypothesis, testing, failure, refinement, and eventual breakthrough. By teaching students these patterns, we equip them with critical thinking skills that apply to any new technology, not just AI. So, what are the practical implications of this history for our classrooms right now? What do we do with this history? The most important mindset shift is moving from preparing students to compete against AI to preparing them to collaborate with it. AI literacy is now as essential as digital literacy was 20 years ago. We can use the four eras we just discussed to teach AI history, showing students that progress is cyclical and not magical. We must also emphasize AI's limitations. Students need to know what AI cannot do and why, which helps them understand its appropriate use. This frees us up to focus on the uniquely human skills that AI cannot replicate: creativity, ethical reasoning, and emotional intelligence. And finally, we must integrate these tools thoughtfully. Use ChatGPT as a learning aid, a powerful calculator for language, not a replacement for thinking. We also have a responsibility to address the ethical concerns around bias and misinformation. We frame AI as an augmentation tool that enhances human capability, not a replacement. This is the challenge and the opportunity of our time. Thank you so much for your time and engagement today.